Welcome to Edu-ca-te. We are given a circuit below which consists of a 6 ohms and 15 ohms resistors which are connected in parallel. These resistors are connected in parallel, and then there's an unknown resistor R in series. So this is a resistor R is in series, and then we have got an ammeter here and the high resistance voltmeter I mean. So here today we are asked to actually solve a set of questions based on this electrical circuit, but then we're going to actually do an analysis exactly on what to measure on the circuit. Okay, so first here we'll find our total voltage because this is the battery, and at ammeter A we'll find our total current because it is directly connected to the battery, so it means all the current is coming from the battery. Therefore A is our total current. And also just know that we have got our parallel and our series part. Here we've got our series part, here's our series, and then let me mark our parallel part in blue. So this is the part in parallel. Remember that for a part of a circuit to be parallel is when the total current divides into two different parts. So here you can see that the other current goes that way, the other one goes downwards. So it means that that's our parallel combination. Otherwise, the red part is just means it's series. So it means the current we're going to find at resistor R is also the total current. Therefore, the ammeter A and resistor R have got the same measurement of current. So now we are asked to first define the term power. Okay, but then we're given a piece of information that states that the total power dissipated in the parallel part is 50 watts. So this is the magnitude of the electrical power dissipated in the parallel part, meaning that the power in the parallel part is equals to 50 watts. So that's the information which we are given in the circuit. So here we are now asked to define the term power. What is power? I recommend you to watch our previous video before you go on with this video, because most of the concepts are surrounding power. We have already covered them in our previous video. So power is defined as the rate at which work is done. So it is the rate at which work is done. It means that we're just asking how fast or slow is work done. So you can say work done, or you can say energy transferred, because for there to be work there need to be energy. That's why energy is the ability to do work. So power is defined as the rate at which work is done or energy is transferred. So now let's go to the calculations. We are asked to calculate the effective resistance of the parallel combination. Okay, let us check which one is our parallel combination. Our parallel combination is the blue part. So the blue part has got two resistors, be it 6 ohms and 15 ohms. So 6 ohms and 15 ohms are actually asked to calculate the effective resistance. So we're talking about the parallel resistance of the parallel combination. Therefore, we use the formula 1 over R parallel is equals to 1 over the resistance of 6 ohms which we have plus the resistance of 15 ohms. So we're having two resistors here. So here is now substitution. 1 over 6 plus 1 over 15 is equals to 1 over R parallel. And then we'll go straight to the answer, whereby the R parallel is equal to 4,29 ohms. So it means that the parallel part or the parallel combination of the circuit has got a total resistance of 4,29 ohms. So this is the formula by which we will use to actually calculate the effective resistance for the parallel combination. So it means it's 1 mark here and another mark over there. So it's only 2 marks. So let us go to question number 1.3, which asks us to calculate the voltage across the resistors in parallel. Well, remember that we already have something in parallel. Remember that in question 1.2, our previous question, we calculated the parallel resistance, which is 4,29. So for the parallel combination, we now have the parallel resistance, and we are also given in the statement the power dissipated by the parallel part. So it means we've got the parallel power. So we've got two of those things. So here we have to think of an equation that can help us calculate the voltage across the resistors in parallel? Well, there is a power equation. We say it's a power equation because we have been given power and we have got a resistance. So we have got an equation that says P is equals to V squared over R. So here we know that we have got our power for the parallel part, and then we have got our resistance for the parallel part. We have calculated that in our previous question, so make sure that you answer questions in the correct order. So here we're going to substitute 50 for our power, because we have been told that the power dissipated by the parallel part is 50 watts, and then we do not have our voltage, but we do have our resistance to be 4.29 ohms. Therefore, our voltage over there across the parallel part, we actually say this is V parallel, is equals to 14.65 volts. So you are done. It's only 3 marks. It's formula, substitution, and answer. And now we go to our last question that asks us to calculate the current through resistor R. Okay, let's look at resistor R. Well, resistor R, remember that we have made our labels already, so it's important to label what exactly is measured within resistor R. Resistor R is the only resistor in series, or the red part. So it means that resistor R is measuring the total current. So here, they're asking us to calculate the current in resistor R. It's the same as them asking us to calculate the total current of the circuit. So how do we actually calculate the total current? Well, since we have got the power which is dissipated by the power dissipated by the parallel part, we can use that to actually calculate exactly how much current passes through resistor R. So here, now let us go on and calculate. So we can use the equation that states that P is equals to VI, whereby P is actually the power through the parallel part, is equals to the voltage through the parallel part times the current through the parallel part. Okay, so here let us now calculate. So don't get confused as to exactly why did you use power of the parallel whilst the resistor R is in series. Remember that the total current is the current which gets into this parallel combination. So the total current and the parallel current in this case will be the same, because the current received amongst these resistors connected in parallel comes from the total current. That is why it is important for us to use the power of the parallel part, so that we can actually determine how much current is in the parallel part. Remember that the parallel part receives current from the total current, or from the battery. So the total current over there will be equals to the parallel current. So here, let us calculate the parallel current over there. Because we have got 50 watts as our parallel power, and we have got our parallel voltage as 14.65 volts times the parallel current. So now we just have to eliminate 14.65 over here and then 14.65 over here. Therefore, we will remain with the parallel current to be 3.41 amperes. So it means that the current which is received by the whole parallel, all of the parallel part, is 3.41 amperes. So it means now we have got something to do with what? With the total current. Remember that the total current is equal to the parallel current in this case, because the current that is received in the parallel part comes from the total current. So now we can use that total current to actually determine what is the reading here on R. Okay, so now that we have found out our value for the current of R, for the current of the parallel part, let us see its relation to R. So here, the current of the parallel part says 3.541 amperes. But then remember that we said that the parallel current comes from the total current. Therefore, they are equal. So it means the total current is also equal to 3.41 amperes. So remember that ammeter A and R are actually in series. So it means they are all measuring the total current. Therefore, the current passing through R is the same as 3.41 as well. So here we actually solved the question. Therefore, you can conclude and say that the parallel current is equals to the total current and is also equals to the current of resistor R, which is equals to 3.41 amperes. Thank you for watching. Don't forget to subscribe. Tell your friends to stay tuned.